Welcome everyone. So here we are discussing the GATE 2021 instrumentation paper. I wish all of you have done your exams very well and wish you hearty success and a very successful results in your GATE exam. So GATE 21 instrumentation engineering is what we are analyzing. Paper was really interesting and very straightforward, all very direct questions, nothing, no convoluted questions, all were pretty straightforward questions this year. So we are going to look at a couple of questions from control systems. X of t is given by root 2 sine t u of t. X of t is applied to g of s equal to 1 by s plus 1. The maximum value of output at steady state is. This is the question. So let's start solving this. So x of t is given. X of t is root 2 sine t u of t. This is my g of s. X of t is the input, y of t is the output. So what will be x of s? X of s is going to be root 2, is going to remain root 2 sine t u of t on Laplace transform will give me 1 by s square plus 1. And g of s is that, therefore y of s. So y of t is nothing but g of t convolved with x of t. That means y of s will be g of s into x of s. So this will be 1 by s plus 1 into root 2 divided by s square plus 1. So this root 2 we will keep it outside. We will take it back when needed. S plus 1 into s square plus 1. I'm going to write this as as plus b divided by s square plus 1. I'm splitting into partial fractions divided by c into c divided by s plus 1 plus. So standard rules of partial fraction, let's see. So if I have to split, what will I get? So 1 will be equal to as plus b into s plus 1 plus c into s square plus 1. Upon further simplification, what we get? As plus b, right? Sorry. As plus b. So if I a square plus a plus b into s plus b, correct? As plus b is correct. Plus c square plus c. So if I compare the coefficients of this polynomial, here we have a polynomial in s, here it's a constant. So if I compare the coefficients of s square on both sides, what we will get? So comparing the coefficient of s square, s and constant on both sides, what do we get? 1 is equal to a plus c, a plus b is equal to 0, b plus c is equal to 1, or b is equal to 1 minus c. So I'm going to substitute this here. So if I substitute this here, what will I get? B is equal to 1 minus c. If I'm going to substitute it here, what I'm going to get? A plus 1 minus c equal to 0, or a minus c is equal to 1. Also I have a plus c is also 1. A plus c is 0, sorry, a plus c is 0, right? A and c are the coefficients of s square, right? A plus c is 0. A plus c equal to 0 and a minus c is equal to minus 1. So if I simplify, what will I get? 2a equal to minus 1, or a equal to minus 1 by 2. So c is equal to minus a by this equation. C is equal to minus a, which is plus half. And what will be b? B is b plus c is equal to 1. So b is also half. So therefore root 2 into 1 by s plus 1 into s square plus 1 becomes root 2 into minus 1 by 2 s by s square plus 1 plus 1 by 2 into 1 by s square plus 1 plus 1 by 2 into 1 by s plus 1. This is what we get. Correct. So that s plus 1 by s square plus 1 also I am splitting this as s by s square plus 1 plus 1 by s square plus 1. I am splitting that. So we had as plus b divided by s square plus 1, right? So I split this term as as by s square plus 1 plus b by s square plus 1. This is what I split this. Okay. So now everywhere there's a 1 by 2. I'm going to take that 1 by 2 common outside. So 1 by 2 comes common. There's a root 2 here. So effectively it will become 1 by root 2. So I have 1 by s square plus 1 minus s by s square plus 1 plus 1 by s plus 1. This is my y of s. Therefore, y of t, I have to take inverse Laplace transform 1 by root 2. 1 by s square plus 1 will give me sin t. S by s square plus 1 will give me cos t. Plus this will give me e power minus t. Everything there will be a u of t associated with that. So now, what is being asked? Steady state. Steady state. That means steady state means t tends to infinity. As t tends to infinity, clearly if you look at this, whatever we are having here, I'm sorry, here, this fellow, e power minus t is going to become 0. Correct? Clearly is going to become 0. Correct? So this value is going to tend to 0. So therefore, I will get y of t. Y steady state will be 1 by root 2 into sin t minus cos t u of t. Now there's an interesting thing. So what will be the maximum value of sin t minus cos t? So this is now a problem in calculus. So sin t minus cos t. What can be the maximum value of this function? Sin t minus cos t. So f dash of t, if you differentiate, what you will get? Cos t plus sin t. This should be equal to 0, or cos t is equal to minus sin t, or tan t equal to minus 1 implies t is equal to 135 degrees. At t equal to 135 degrees, if you see the value of this will be 1 by root 2 minus sin 1 cos 135 will be minus 1 by root 2. Minus of minus will become plus 1 by root 2. This is what I will get. So this will be 2 by root 2. So if I substitute this here, I will get 1 by root 2 into 2 by root 2. U of t is 1. So if you see, effectively this will be 1. So this is the answer. So maximum y of t in steady state will be 1. That's clearly known, right? When I have a sine and cos, the maximum value will be 1. No, it cannot go beyond 1. So that's what we are seeing. Okay. That will be the maximum. So this is the solution. Let's go to the next problem. Next problem is much more interesting. Let me pick the problem. You have a C of S and a G of S, and it's a unity feedback system. Okay. This is my unity feedback system, and it's given that G of S is equal to 1 by S plus 1 into S plus 3. C of S is equal to S plus 3 minus J into S plus 3 plus J into K divided by S. Find condition on K for stability. This is the question. Options, 4 options are given. K greater than 0, minus 1 less than K less than 1, K less than 0, all K. That is, system is stable for all K. For all K, system is stable. This is what is the question. So this is also a very, very straightforward standard question. So let us look at our C of S. C of S is given K into S plus 3 minus J into s plus 3 plus j divided by s, right? So let us simplify this. So I'm going to just put another set of brackets around this so that we can simplify this. So I'm going to just put this and write this as a conjugate terms, s minus j and s plus 3 into j, like that. So this can be written as now s plus 3 the whole square plus 1 divided by s the whole into k. So s plus 3 the whole square will give me s square plus 6s plus 9 plus 1 will give me 10 by s into k. This is what is my c of s. So now my g of s is 1 by s plus 1 into s plus 3, correct? This is what we have, right? 1 by s plus 1 into s plus 3. Perfect. So now for stability we analyze. For stability we analyze characteristic equation, that is 1 plus gh equal to 0, or in this case it's 1 plus cg equal to 0, correct? There is h is 1, the forward part transfer function is g into c, so it is gc equal 1 plus gc equal to 0. So that gives me 1 plus 1 by s plus 1 into s plus 3 k into s square plus 6s plus 10 divided by s is equal to 0. So if I simplify this, what will I get? I will get s into s plus 1 into s plus 3 plus k into s square plus 6s plus 10 equal to 0. This is what I will get. Okay. So this is s square 5s plus, sorry, 4s plus 3. So I'm going to write this as s cube plus 4s square plus 3s plus ks square plus 6ks plus 10k equal to 0. I'm just simplifying it further. Okay, nothing more. So s cube plus, I'm going to club all the s square terms. So I will get 4 plus k square plus 3 plus 6k into s plus 10k equal to 0. 3 plus 6, yeah, correct. So now I'm going to plot the Routh table. If I plot the Routh table, what will I get? S cube, s square, s power 1, s power 0. I will have 1, 4, sorry, let me write it clearly. 3 plus 6k, 4 plus k, 10k, correct? So here I'm going to get one expression. So let me consider that as x. We'll come to that, don't worry. Here it will be 0. What will be this? This will be 10k into x minus 0 divided by x, which is 10k, 0. Now by looking at this row, 10k should be greater than 0 because we want all the terms to be positive, correct? There should be no sign changes in the Routh-Hurwitz table, so all the terms should be positive here. So 10k should be greater than 0 or k should be greater than 0. This is not the yet, we need to look at this also, but by looking at this is what? By looking at this, we want x greater than 0. Now we don't know what is x. Let us calculate what is x. So what is that? It will be 4 plus k into 6 plus 3k minus 10k divided by 4 plus k greater than 0. So 4 plus k goes that side, it will become cancelled. So now if I simplify this, I will get 24 plus 3k, wait, 24 plus 3k, the 12k plus 6k. 12k plus 6k is 18k minus 10k will give me 8k plus 3k square, correct? Should be greater than 0. Yeah, 1 by s plus 1 into s plus 3 and k into s plus 3 minus j and s plus 3 plus j divided by s. Perfect. Yeah, s square plus 6s plus 10. Yes, perfect. Is all correct. And here it is going to be s square plus 4s plus 3. So s cube k square plus 6ks plus 10k. Yeah. So it is plus 3k. Yeah. So if you see here, what you will get, let us simplify this equation now. So you will say k, let's say if I equate this to 0, this should be greater than 0, right? So let us say equate this to 0. If I equate this to 0, k will be what? Minus b plus or minus square root of b square minus 4ac, correct? So this will become imaginary. So it will become some number. Okay. So clearly k should be greater than a negative number. That's what it is coming to. Correct. So k greater than negative number and k greater than 0, which is more stringent. K greater than 0 is the most stringent condition. So it is going to be k greater than 0. This is my solution. Okay. Thank you guys. Thank you.